No, I think I'm recording. Okay, perfect. All right. So binomial distribution, guys. I think last time I tried to explain how to compute a binomial, the probability of a binomial distribution. So I'm gonna just remind you very quickly what's a binomial, what's a binomial distribution, etc., and what we need to compute a binomial distribution. So yeah, just remind you what's a binomial experiment or binomial distribution. So binomial experiment is that's an experiment with only two possible outcomes, or only two outcomes of interest. So a binomial experiment. So it's an experiment with.
Call me when you're done. If I don't answer, I'm not practice. That's the problem.
With only two, I think I need to mute someone. Okay. Yeah, with only two outcomes. Of interest. So the two outcomes of interest, they're often denoted by S, and that would be like a success, and F, and that would be like a failure, right? So we're gonna have like two possible outcomes. So we're gonna have S, capital S. So capital S stands for success, right? And then we're gonna have F, capital F, and that will be failure. Okay. Then we denote the probability of success by P. So P, so when I say P, that's the probability of success, probability of capital S, right? And Q, that's the probability of failure. So again, guys, what you have to keep in mind is that P plus Q, that will be equal to 1. It's always equal to 1. P plus Q, probability of success. So of course, so either you're gonna succeed or you're gonna fail, right? So probability of success plus probability of failure, that will be equal to 1, which is of course, so 1, it's just 100%, right? So P plus Q, that's always equal to 1. Anyway, so yeah, so we have these two outcomes: success, failure, probability of success, that's P, probability of failure, that's Q. And then we have a fixed number of trials denoted by N. So N will denote, oops. So N, so this is the number of trials. Okay, it's fixed. And then the goal, of course, would be to compute the goal would be to compute, of course, the probability of to compute or to determine the probability of R successes out of N trials. The probability of N successes out of N trials. Sorry, R successes, I mean. So R, that would be the number of successes out of N trials. Okay. I mean, I think I gave a couple of examples on Wednesday last week, but so let me just remind you very quickly, like an example. An example would be you know, for example, you have multiple choice questions. Let's say you have like 3 multiple choice questions, 3 multiple choice questions. So let's say this is example number 1. And so each multiple choice question has like, let's say 4 choices. So each question has like 4 choices. Okay, and you want to compute, let's say, so what's the probability of, or what's the probability to, so what's the probability that you get like, of course, you're gonna randomly select your answers. Okay, so then what's the probability that we get, let's say, just one right answer, exactly one right answer. Okay, so yeah, so here, of course, when you answer a question, right, either you're going to succeed or you're going to fail. If you get the right answer, you succeed. If you get the wrong answer, of course, you fail. Now, so what will be the probability of success here when you answer a question? Because you have 4 choices. Of course, there's only one right choice out of 4. So probability of success here would be 1 out of 4, right? So, so in this problem, so S, this is when you get a right answer. So answer correctly, right? And F, that's when you answer incorrectly, right? So probability of success here, because it's one correct choice out of 4, so that's 1/4. So that's 25%. That's the probability of success. So that's my P. And my Q, it's just because, of course, it's 3 out of 4 because there are 3 wrong answers or choices out of 4. So that's 3/4, and that's 75%. And as I said, I mean, P plus Q, as you can see here, P plus Q, that's 100%, which is 1. Anyway, now what's the goal of this question? So the goal is to find the probability that we get one right, one right answer. So we need one success here, right? This is one right, so that's one success. Okay, so the number of successes here are, we are looking for one success out of 3 different questions, right? So R here would be 1, and because we need one right answer, because we need, I mean, we want to compute the probability that we get one right answer, so we need one right. Now, what's the number of trials? Because we're going to answer like 3 different questions. So each time, of course, you hope you get one right answer. So the number of trials would be 3 because we have 3 different questions. Because we have 3 questions. Okay. So of course, then the goal would be to find probability that R is equal to 1, right? The probability that we get one right answer. So we need to compute this, right? This is a probability to the probability that you get one right answer. Out of the 3 questions. Any questions so far, guys? So this is just to remind you, the setting, right? So we have this probability of success, probability of failure, et cetera, et cetera. So then, so last time I tried to explain, so the formula for the binomial distribution. So the formula, just to remind you here. So the formula we said, so P of R, the probability of R successes, okay? This is supposed to be equal to, first we have N choose R. So we have capital C subscript N comma R, right? This is N choose R. Okay, times P to the capital, P, this is, of course, this is probability of success. So P to the power R. Okay, because we need R successes, right? This is the probability of R successes, right? So that's why it's the probability of success to the power R, or to the exponent R, times, of course, Q. So you're gonna fail, of course, if you succeed. If you get, let's say, if you succeed R times, so it means you're gonna fail like N minus R times, right? Because in total we have N trials. So if you succeed N times, it means you're gonna fail N minus R. So this is Q to the power N minus R. Okay. And I mean, as I said, so I tried to explain last time, Wednesday last week, why this formula is true. Well, we said because, this N choose R, this is like the number of ways. So this is the number of ways, to choose R, the number of ways to choose R elements, from a set of N. R elements from a set of N. Okay. So, for example, I'm not sure if I gave this example last week, but anyway, so let's come back to this example with the three multiple choice questions, right? We have three multiple choice questions, and we want to compute the probability that R is equal to 1, right? This is, so we want to compute this thing here. This is the probability that you get one right answer. To get exactly one right answer, right? So it's exactly one right. Exactly one right. So the question, guys, first, you need to figure out, or you need to find, so how many, how many ways, or how many possible outcomes where you can get exactly one right answer. So you have three different questions, right? So for example, you can answer correctly the first, right? That will be success in the first, and then you fail, the second and the third. Okay, that's one possible outcome where you get exactly one right answer. You can fail in the first, and then succeed in the second, and then fail in the third. So this is another outcome where you get exactly one right answer. You have just exactly one success, right? Or of course you can fail in the first, the second, and then you succeed in the third question, right? So here we have three. This is three. So this is the number of ways to get exactly one answer out of three. To get exactly one right answer. Exactly one right answer out of three. Okay. So this is why we have this N choose R. So this number here, 3. So this is like you're gonna. This is like 3 choose 1. So what I'm saying here is that 3 choose 1 would be equal to 3, because we have 3 different ways to get one right answer out of 3. So This is like, we have three ways, three different ways to get, or three different combinations, to get one right answer. Exactly one right answer out of three. Okay. So again, this number, the first number is n. This is this three here, the first three, that's your n, that's the number of trials. And the second number here, so 3, 1, the second number, that's the number of successes, your r. You're interested in getting one right answer out of 3. So that's 3, choose 1. Any questions so far, guys? Let me see the chat. All right, no questions. All right, perfect. So yeah, so you see, you have like 3 different ways to get exactly one right answer. Now, you need to compute, the probability of each possible outcome. So for example, you need to compute a probability of a success, then a failure, then a failure, right? That will be like the first possible way to get exactly one right answer, right? It's like to answer correctly the first, then you get the second, you get the, you answer incorrectly to the second and to the third, right? So this is success and then failure, right? So this is like saying probably that you get the right answer first, and then you fail in the second, and then you fail in the third. Okay. But then, when you have and, so as we discussed in chapter 5, multiplication rule, when you have and, it means you need to multiply, right? So this is like probability of S, because here actually we have like independent events, because like we have independent trials. So this is probability of success times probability of failure times probability of failure. Right, so this is like, so here I use the multiplication rule, right? This is from chapter 5, multiplication rule. And then, probability of success, that's my P, times probability of failure, that's Q, times Q. So as you can see, this is like P to the power 1, because you get one right answer, times Q, so you're gonna fail in the second and the third, so that will be Q squared. Okay, so 1 would be like, 1, that's like my R, and 2, this is like N minus R, right? Because we have N is 3, we have 3 different questions, right? Etc. So that's for the first outcome, right? The first outcome, the probability of the first outcome, it's P Q squared. You can do the same thing for the probability of the second outcome. You're gonna also get P, because it's 1 success and 2 failures. So it's the same thing, gonna get PQ squared, and then it's another PQ squared, right? So in total, as you can see here, we have like 3 times P times Q squared. And it's 3 because there are like 3 different ways to get this one right answer, right? So that's why, so probability of that R is equal to 1 here, that will be N choose R. So we have 3 trials, 3 different questions. We want to get one right answer out of 3. So this is 3 choose 1 times P to the power R. We need 1 success times Q to the power. So again, if you succeed in answering correctly the first one question, then you're gonna fail the other 2, right? So that's Q square. So so this is, again, this is like 3, this is like N, this is like R, this is R, and this is 2, this is N minus R. All right. And so in general, so this is just an example, of course. So in general, as I said, so in general, so probability of R successes would be N choose R we compute a number of ways to get the, R successes out of n trials times, of course, probability of success to the power R times Q to the power n minus R. All right, and then I try to explain how do we compute this, this n choose R. And I think I said, so this n choose R, it's actually equal. So I introduced factorials Wednesday last week, right? And I think I explained so that so this number here, n choose R, actually would be n factorials over R factorials times n minus R factorials, right? So again, this n factorial, so just to remind you here, I mean, we discussed this last Wednesday, but n factorial, this is like when you multiply, 1 times 2 times 3, etc., etc. But then you have to stop because it's n factorial. So you have to stop at n, right? For example, if you have like 6 factorial, that would be 1 times 2, 3, 4, 5 times 6, right? Etc. And just to remind you, so we said 1 factorial, that would be 1, and 0 factorial by convention, it's 1, right? So again, this n exclamation point, that's n factorial, right? This is called n. This is called n factorial. Okay. All right. So today, what we're gonna do, guys, we're gonna try to practice a little bit. We're gonna have a couple of exercises, and we're gonna try to apply this formula, right? So I mean, to compute this probability of R successes, of course, you can use the calculator, or there is a table, in the formula sheet. In your formula sheet, there's like a table in the second page. And in the table, you can find, the binomial probability distribution. But probably I'm going to explain this like Wednesday when I meet you in person, how to use this table. But anyway, so let's have a couple of examples or exercises. So first exercise. So exercise number 1. I don't think we had time to do any exercise Wednesday last week, right? If I'm not mistaken. Did we? I don't think so, right? I mean,
No, we didn't.
We didn't, right? Okay, perfect. Okay, sounds good. All right, so first exercise. So in this first exercise, guys, I'm gonna try to explain the exercise, of course. But so we're gonna do it together. But then I'm gonna give you another exercise, and I will give you some time to think about it, right? So let's do this one, the first exercise, together. So first exercise says the following. So we have sociologists, and I think I tried to explain how to find like this success, failure, number of trials of this example, but of course we didn't compute any probability, right? Anyway, so we have like the following. Sociologists, they say that 90%, so this is from the textbook, of course, so 90% of married women dislike their mother-in-law. Okay. So we have a group of let's say a group of 6 married women. A group of 6 married women, and we want to find the following. So what's the probability that first, that all of them dislike their mother-in-law. So I'm gonna just write ML for mother-in-law, which is actually my initials. Anyway, number 2, none of them dislike their mother-in-law. And then exactly 2 of them dislike their mother-in-law. For at least 4 of them dislike their mother-in-law. And the last one, no more than 3 of them dislike their mother-in-law. So no more than 3. 3 of them, of course, dislike their mother-in-law. Okay. So yeah. So let's find. Let's answer this exercise together. So first, number 1. Well, before the number 1, so we need to understand that this is a binomial experiment. Remember what we said for binomial experiment. It's an experiment with only 2 possible outcomes, right? Or 2 possible, 2 possible outcomes, either success or failure. Of course, here you don't really see the success and the failure, right? So, but the thing is, you're gonna define. So you're gonna read carefully the exercise or the question, and you're gonna try to see what will be the success or the failure in the experiment, right? So for example here, any guess, guys, what will be, I think we discussed this, but I'm not sure, but what will be a success in this experiment? So this experiment, we have this group of 6 women, married women, right? And we are interested in married women, right, who dislike their mother-in-law, right? So what will be a success for you? Any guess?
Married women who dislike their mother-in-law.
Absolutely. So you have this group of 6 married women, right? So you're gonna select like a random married woman, right? And then you want to see if she dislike or not her mother-in-law, right? So it's like the two outcomes here is that either she's gonna dislike her mother-in-law or she's gonna not dislike her mother-in-law, right? So yeah, thank you, Asanta. That's so just here, I'm gonna just write. So before answering the first question, I'm gonna just try to explain the success and the failure here. So we have a married woman and you want to see if the married woman dislike or not her mother-in-law, right? So as Asamta said, a success would be success will be then success will be that a married woman dislike her mother-in-law, and a failure, right? That's when the married woman actually doesn't dislike her mother-in-law. Now the question is, when you pick at random a married woman, what's the probability of success? What's the probability that she dislike her mother-in-law? When you pick at random a married woman?
90.
90%. Thank you, Asanta. Yeah, because in the entire, what we are saying here, the sociologists, they are saying like in the entire population, right? 90% of married women dislike their mother-in-law. So it means that if you select random married woman, there is 90% chance that she dislike her mother-in-law, right? So the probability of success that the married woman dislike her mother-in-law is 90%. So the probability of success P, so P here would be 90%, or in other words, this is 0.90. And of course, probability of failure, remember guys, P plus Q, it's 100%. So if P is 90%, Q would be, any guess?
10%.
10%, thank you. 10%. Or again, remember guys, we need 2 digits. So 2 digits after, so that would be after the decimal point, that would be 0.10. Now, what's the number of trials here in this question? So how many times we're gonna check if the married woman is gonna dislike or not her mother-in-law? Any guess? Number of trials? And
equals 6.
6. Thank you, Gina Booher. Absolutely, because we have this group of 6 women, right? And so we're gonna check each time if the married woman dislike or not her mother-in-law. So it's like you're gonna try to see 6 times if the married woman dislike her mother-in-law or not, right? So the number of trials will be 6. This number here, right here. Okay, so n is equal to 6. N is equal to 6. All right. Now we can answer the first question. So what's the goal in the first question, right? Remember, in the binomial experiment, the goal is to find the probability of our successes, right? So how many success you need in the first, in the first question? All of them dislike their mother-in-law. So how many successes? Remember, a success is when a married woman dislike her mother-in-law, right? So how many successes we need in the first question? Any guess? So you see, we need all of them to dislike their mother-in-law, right? So the number of successes here would be 6 in the first question, right? We have a group of 6 married women, and we are looking for the probability that all of them dislike their mother-in-law. And a success for us is when a married woman dislike her mother-in-law. So the number of successes here in the first question is 6, right? So we are looking, in the first question, we are looking for the probability that R is equal to 6. All of them, all the married women in the group of 6 dislike their mother-in-law. So all of them, all of them dislike their mother-in-law. Right? Now, any question why R is equal to 6? I mean, I hope you see why R is 6, right? Because again, we need all of them to dislike their mother-in-law, and the success is when a married woman dislike her mother-in-law. So we're gonna apply the formula, of course. So this is actually equal Just remind you the formula. So P of R is supposed to be N choose R, P to the R times Q to the N minus R. Okay, so this is supposed to be equal to, because my N is 6, remember we said N trials, number of trials is 6, and R in this problem is a 6, right? My R is also 6. So this would be 6, and so this is 6, and here's 6, right? So we're gonna have like 6 choose 6, then times probability of success to the power 6 times probability of failure to the power 6 minus 6. Right? So again, this is just the binomial. I'm applying the binomial. This is the binomial formula, distribution formula. All right. So yeah, so then this probability would be equal to, remember N choose R, N choose R, we said is like N factorials over R factorials times N minus R factorial, right? So if N is 6, R is 6, they'll be equal to, we're gonna have like 6 factorial over 6 factorial times 6 minus 6 N minus R factorial, right? Of course, 6 minus 6 would be 0. So that's like 0 factorial. And as I said, 0 factorial is just 1 times P. P, we said probability of success. That's 90% or 0.90. So that's 0.90 to the power 6 times Q. As I said, Q is 0.10 to the power 6 minus 6, of course, is just 0. And remember, guys, any number to the power 0, just remind you here, x to the power 0 is equal to 1, right? So as I said, so we can use a calculator to compute this. I mean, of course, you can say, well, so let me just explain here. The first way to compute this, well, you can use a calculator. So you can say, well, so this is 6 factorial. So that's like 1 times 2, 4 times 5 times 6 over 6 factorial. This is the same thing. And times 0 factorial. 0 factorial is just 1, right? Times, 0.90 to the power 6. And then, as I said, any non-zero number to the power 0 is 1. So this is times 1. Anyway, so you can see here, actually, you can just cancel out this, this 6 over 6, 5 over 5, 4 over 4. This is just like 1 over 1, which is equal to 1, right? So, I mean, basically, this is, this probability is just, so R is equal to 6. I mean, this is just equal to 1. So it's going to be just 0.90 to the power 6, right? So this is like, 0.90 times 0.90, 6 times. Anyway, so the answer actually would be 0.531. Okay, or if you use percentage, remember for the percentage, we take 2 digits after the decimal point. So this is actually 53.1%. So what we are saying here, guys, I mean, the interpretation of this answer. So what we are saying is that there is 53.1% chance that all of them dislike their mother-in-law, right? So again, we have this group of 6 women, and there is 53.1% chance that all of them dislike their mother-in-law. Okay. Any question, guys, how I got this 0.531 or the 53.1%? All right, so this is the first way. I mean, this is like using calculator, you know, and then you try also to simplify your factorial. I mean, factorial can be horrible. I mean, you can, if you have like, imagine you have your n is equal to 10 or 20, you're gonna have like 20 factorial. It's a lot, right? So that's why there's another way actually to compute this. A second way to compute this, and this is actually using, as I said, our formula sheet, the table, and I don't know if you have the, I don't know if I can share my, I can share my formula sheet. Let me see. So the second way is to use our formula sheet. The second page, table number 2. Well, I guess I can share it in my screen, but I guess I'm gonna need a couple of minutes. Do you have it, guys? The formula sheet. But anyway, I guess probably we can discuss this on Wednesday in person. It's better. But I can always try to share my screen here so you can see what I'm talking about. Where's the formula sheet? It's somewhere in review. Do I have it? Okay, I guess I need to go to my email. Okay, let me see, where's my formula sheet? Okay, it's gonna take more than 1 minute, I guess. I have a trouble to find my formula sheet, so okay. You know what, guys? I can probably. Sorry about that. I mean, I for some reason I don't see it. Okay, I can probably share my screen. So that was a formula sheet. Okay, not this one. This is the view sheet. Okay. Yes. So I'm gonna share my screen for 1 second, guys. Just so you can see. So I'm gonna stop sharing here. I'm gonna stop sharing here, and I'm gonna share my screen. Share. All right. Do you see the formula sheet?
Yes.
Yes. Okay. Perfect. Thank you. All right. So as I said, this is table number 2 in this formula sheet. So this is, I think, the third page in the formula sheet. So in this table, guys, as I said, though, this table actually is going to give you the answer. So first, like in our problem, remember, we had like n equal to 6, right? Because we had this group of 6 married women, right? So n is equal to 6. So you see here the first column, n, right? And then here is 6. So so there, that's my n. Now our r, number of successes r. So r is like the second column. Okay, so in our case, in the first question, r is also 6, right? So n is 6, and then we have like r goes from 0 to 6. So in our question, of course, r is equal to 6, and then next we have the p. You see the P, you have the 0.01, 0.05, 0.10, 0.15. That's supposed to be your P, okay? And so like in our problem, P is 0.90. So this is like, before 0. The last column we have 0.95, right? And so before 0.95, we have 0.90 or 0.90. So if you go to, n equal to 6 and r is equal to 6, and then in the column where P is 0.90, you can see the 0.531, right? I don't know if you see so do you see the 0.531?
Yes, we see
The
it.
blue, you see it?
Yes,
With the
Yes.
blue? Okay,
we see it.
thank
Yes.
you. Thank you. Thank you. So yeah, yeah. So you get the answer just from the table. You don't have to compute the factorial or the entries R or whatever. Once you know your N, you know your R, you know your probability of success P, then you can just use this table. This table to get the answer. And another thing, guys. So this table, the N, of course. We don't have all the answers for all the N's. N here, it goes from like 2, and then so we have 8, 9, 10, 11, 15, and then 16, and then the last N here in the covered in the table is 20, right? So that's good. Anyway, so what I'm saying is, like in the test or in the final, again, I will discuss this again on Wednesday because this is really important. So you don't have waste your time, computing all the things with the calculator. You can just use this table, and you can get your answer. All right, so I'm gonna stop sharing, unless there's a question here about the about this table. But you can see, right? Like first column you have N, the second column you have R, and then after that the 0.01, 0.05. It corresponds to your P, right? Yeah. So I'm gonna stop sharing, guys. Stop sharing. Okay. All right. So I'm gonna share again my. All right. You see the board?
Yeah.
Yes. Okay. Perfect. Okay. Yeah. So yeah. So you get the answer here. This is 0.5v1 from the table. So this is, so you can just use this table number 2 in the formula sheet. All right. So next question, number 2.
Hi, Mister. I have a question real quick.
Yeah, please.
So, is the review sheet for the test next week? Is it already on Blackboard?
You mean the second test?
Yeah, the second test. Is it on Blackboard already?
No, it's not. It's not. No, because the second test is like December. I said it's December 8th, right? So I'm gonna post the review sheet like a week, probably a week or 2 weeks before. So
Okay, because I remember
yeah.
the first test. I think the review sheet wasn't posted till like the day we went over it in class, and I had problems on the next test because we didn't get to review the whole thing.
Yeah, I posted the review sheet like a week before the test. That's usually what I do. Yeah, a week before the test. That's usually what I do. Yeah, because I don't know exactly what's gonna be in the. Sometimes I cover everything, what I want to cover, but so that's why it's just I wait until like a week before the test to to post the review sheet, because then I know exactly what's gonna be in the test.
All right.
Yeah.
Thank you.
Mm-hmm. Any other question, guys? Let me see the chat. Okay. All right. So now let me just move to the next question, right? So number 2, none of them dislike their mother-in-law, right? So number 2 here, none of them dislike their mother-in-law. So guys, the P doesn't change. The P is always the 90% or the 0.90, right? The P doesn't change. The number of trials, and it doesn't change. We still have the same group of 6 married women, right? So your N is still 6. but what changed here is the R, the number of successes. So how many successes we need in this second question? Any guess? Do you hear me?
Yes, Professor, we hear you.
Oh, okay, you hear me? Okay, I'm sorry. Yeah, so here we are again, guys. I mean, the success, that's when you select a random woman and she disliked her mother-in-law. That's a success. So when I say here, none of them dislike their mother-in-law, it means we need 0 successes or 0 success, because a success is when a married woman dislike her mother-in-law, right? So if you want none of them to dislike their mother-in-law, so the number of successes would be 0. Okay, so for number 2, the R is going to be 0. So so number 2, there'll be probability that R is 0. Okay, so none of them dislike their mother-in-law. Okay, so yeah, so again, it's going to be N choose R, and as I said, N doesn't change, P doesn't change, so N is still 6, right? But in this problem, we need R to be 0. So this is 6, choose 0. Right, so this is your N. This is your R. So 6, choose 0 times P to the power R. That's 0, right? And then Q to the power N minus R. So that's 6 minus R. Sorry, 6 minus 0. So R is 0, as I said. So this is supposed to be R. This is N. And again, this is R. And as I said, P doesn't change. It's always the 0 to 90%, 0.90. So this is 6 choose 0 times 0.90 to the power 0 times the Q, which is 0.10 to the power 6 minus 0. So that's power 6. All right. Now, again, you can use a calculator, but as I said, I mean, probably this Wednesday, I'm going to discuss again this table in the review sheet. Oh, sorry, in the formula sheet. You won't need actually a calculator, right? So just from the table here, number 2. So your N, as I said, is 6, R is 0, and P is 0.90. Okay, so if you check the table, I'm going to check the table. So you see when R is 0, so this is like the first row when N is 6, right? And you have like P is 0.90. So it's like, so if you check the table from the table, it's actually 0.000, right? This is from the table number 2. But actually, this is an approximation, because the right answer, if you do the computations here, will be like 0.00050 zeros and then 1, right? Because of course the answer in the table, it's you have just 3 digits, right, in the table. But as I said, so in the test or in the final, that's enough. I mean, if you just use like 3 digits after your decimal point, then that's enough. All right, so this is actually the exact answer if you use your calculator. Right. Any question, guys? All right. So for number 3, so what does it say, number 3? So how many successes do we need in number 3? So we need exactly 2 of them, right? Exactly 2 of them to dislike their mother-in-law. So again, a success is when the married woman dislike her mother-in-law, right? So if we need exactly 2 of them dislike their mother-in-laws, then the number of successes here would be 2, of course, right? So we need R to be equal to 2 in 3. Same N, same P, same Q, but R would be equal to 2. So for number 3, so we need probability that R is 2. So exactly 2 of them, exactly 2 of them dislike their mother-in-law. Okay, and then so again, so the answer here, it's N choose R. So N is 6 again because we have a group of 6 married women. So 6 choose 2 because our R is 2 in this case, right? Times P to the power R, that's 2, times Q to the power N minus R. So that's like 6 minus 2, right? So in other words, again, the P, so that would be 6 choose 2. P square P is 0.9 or 90 square times the Q. Q is like 0.1 to the power 4. Okay, and then so if you use the table, table number 2. So if you go again, your N is 6, your R is 2 in this case, right? So then the answer, if you check the table, for 0.90, that's so it's going to be equal to the answer from the table will be like 0.001, right? So this is table number 2. Okay. Yeah, just one thing, guys, because this is like a common mistake. Like in the table, you see there's, for example, there's a point, for example, there's 0.05 and 0.50. So of course, 0.05, this is like 5% chance. 0.50, this is 50%, right? So there's a difference between 0.05 and 0.50, right? Okay, so we have, I guess, we have only 8 minutes, right? So for number 4, so N again, it's going to be 6, P it's going to be the 90%, the 0.90. Now, how many successes do we need in number 4? So let's see. Well, it says at least 4 of them dislike their mother-in-law, right? So we need to understand this word at least 4. So what do we mean by at least 4? So at least means the minimum is 4. Okay, so it's 4 or more than 4, right? So at least 4. So when we say at least 4, it means minimum. The minimum is 4. The minimum is 4. So when I say the minimum is 4, of course, it means it's 4 or more. Okay. And because we have a group of 6 married women, so when I say 4 or more, it means 4 or 5 or 6, right? Because the maximum number here, of course, is 6 because we have a group of 6 married women, right? So we need to compute, and so in this problem, in this the question number 4, so we need probability that R is 4. Right? Or R is 5, or R is 6. Okay, so that'll be equal to Well, because we are using or. So remember, when we have or, it means we need to apply the addition rule, right? So when we have or, that will be, we need to apply the addition rule. So just remind you what's the addition rule. So when you say like probability of A or B, that will be probability of A, plus probability of B, and but minus, you are supposed to have probability of A and B. Okay, that's what I mean by the addition rule. The thing is here, guys, I mean, R is equal to 4 and R is equal to 5. It's just impossible because I mean, R is either 4 or 5. R cannot be equal to two different values, right? So probability of A and B, like R is equal to 4 and R is equal to 5, that's impossible. Because, as I said, R cannot be equal to two different values. It can be equal to only one value, right? So it's just P of A plus P of B. So in this case, we're going to have, so this probability would be just probability that R is 4 plus probability that R is 4 plus probability that R is 5 plus probability that R is 6. There is no end here, right? Because as I said, it's going to be just 0. Now, probability that R is 4, you can just use the table. Again, N is 6 and P is 0.90. So when we have R is 4, I think the answer would be 0.098. For R equal to 5, we're going to have 0.354. And when R is 6, I mean, as we discussed in the first question, that's 0.531. So answer, I think it's 0.983. Okay, or 98.3%. So what we are saying here is that at least 4 of them dislike their mother-in-law. There is 98.3% chance that at least 4 of them dislike their mother-in-law. Number 4, let's finish in the last minutes. Number 4, what else? The next one. 5, no more than 3 dislike their mother-in-law, right? No more than 3. So when I say no more than 3, it means the maximum is 3.
Maximum is 3.
Yeah, thank you, Janab, thank you. So for number 5, the maximum is 3 now. So no more than 3. So the maximum is 3. So then we need probability that R is, so then R can be equal to 0. Don't forget 0, right? Because you can have like 0 success, that's less than 3, or R is 1 success, or R is 2, or the maximum, which is 3. Okay, so again, this is less or equal to 3. So then, yeah, so it's just, actually there are 2 different ways to compute this. We can use number 4, the answer of the question number 4 to answer this, because I think this is in number 5, that's like the complement of number 4. But I can explain this. I'm going to explain this probably next time. But let me just say here. So this is like probably that R is 0. That's probably that R is 1. That's probably that R is 2. That's probably that R is 3. So again, just use the table. N is 6 and P is 0.90. So when R is 0, this is just like 0.00, etc. So the final answer Actually, it's 0.017. Right. Yeah. So just or in other words, this is so we have 1.7% chance that no more than 3 dislike their mother-in-law. All right, guys. Well, I guess I'm gonna stop here. So what I'm gonna do on Wednesday, so I'm gonna discuss at least one more exercise, similar exercise. I'm gonna again show you, I'm gonna make sure that you know how to use the table, to answer similar problems. So we're gonna do one more exercise like this on Wednesday, and then I'm gonna try to finish this section next time. All right, thank you for listening, guys. I will see you in person on Wednesday.
Thanks, Boss. Good night.
Thank you, everyone. Good night. Take care.
Good night.
Bye.
Bye.